A platform is supported by spring. A box is placed on the platform, but for quantity marked as X, it is compression, not strain. Strain is the ratio between compression and the original length. Copper has a length and diameter. Young's modulus for copper. What is a spring constant? So we know that E is equal to sigma divided by epsilon, and sigma is F over A. Epsilon in the denominator is delta L over L, and F is K times the extension delta L. Okay, so we can make the elimination, and we have E to be equal to KL over A. So if we want K, it is EA over L, and substituting, we will have K to be times pi d squared over 4, but we have to convert the diameter to meter because we have here the unit in Pascal. So we have 0.00064 squared, over 4, and the denominator here we have L 1.7. We will find the answer to be, the graph shows the extension with force used to stretch it. What is elastic potential energy when extension is 4? It is the area under the graph, so half times the base, 30. Here it is in kilonewton, times the height extension, which is 4, but here in centimeter. So we have the answer. Which describes progressive longitudinal wave. Transfer energy in direction parallel to oscillation is true. So we are limited in C and D. Requires the medium. It is true. So we don't have other option except D. What is phase difference between point B and Q on a progressive wave? Okay, so we have here 90, and we have the phase here is 360 or 0. So between them, we have the phase here is 180, so the difference should be 90 or its equivalent. By its equivalent, we means 90 plus some multiples n of 360. And if you looked to the numbers here, 180 certainly refused. 450, if we subtract it from 360, we find it to be 90. So this is the answer. Okay, you can try the other two and you will find that they cannot be the correct answer. Graph shows variation of displacement of two progressive waves, x and y of same type in same medium. Intensity of wave x is I, and required is intensity of y in terms of intensity of x. So it is a ratio problem where we say Iy over Ix should equal a y squared over ax squared. So Iy equals Ix, which is I, times ay. Here is that is 0.5 by 5 small squares. 5 times the value of the very small square here, 0.05 plus 0.5, so it is 0.75, okay, squared. Ax is 8 very small square from 0, so 8 from 0 times 0.05, the value of very small square, it is equal to 0.4 squared. Using your calculator, you will find this answer. A moving source emits sound of frequency 1200 Hz. Stationary observer hears 960 Hz. Speed of sound is 340. What could be velocity of the source? I have the formula for Doppler effect. F observer equal F source times V over V plus if it moves away, or minus if it moves towards V source. Okay. We have here a decrease in frequency, which means the source is moving away from the observer. So I'll choose the positive sign. Okay. And I'll make some rearrangement and substitute is positive. So this ratio is 0.8. So we have 0.8 times 340 plus 0.8 Vs equals to 340. You can rearrange and find Vs. It will be 85. And as we said, it moves away from the observer, not towards the observer. Light wave passes through a single slit and the diffraction pattern forms. What happens to frequency and speed of wave when it is diffracted? So both of them has no change because diffraction is only about direction. Equation in lambda equal d sine theta used for diffraction grating to find the wavelength of visible light, which quantity is not correct for using an equation. D is distance from grating to screen. No, it's the distance between the lines on grating. Two progressive sound waves move in opposite direction and superpose to form a stationary wave, which statement describes an antinode of this stationary waves. Position where phase difference between two waves is always zero. This is not the definition of antinode. Position where phase difference between two waves is always 180. Again, not the definition. Position where stationary wave has maximum amplitude. Yes, this is the correct answer. Just to remind you, both A and B are related to the constructive and destructive interference. Student connects to loudspeakers to signal generator. As student walks from B to Q, he notices that the loudness of the sound rises and falls repeatedly. What is the cause? Certainly, it is the interference of sound waves. The current in a resistor of constant resistance is 8 milliampere. The power dissipated by resistor is B. Current in resistor increased to 12 milliampere. What is the new power dissipated by resistor? So we know as B equal I squared R, B is proportional to I squared, so B2 is equal to B1 times I2 squared over I1 squared, so it is equal to B times 12 over 8 squared. Piece of wire has resistivity ρ, length L, cross section A. Wire X has resistance R. Second piece of wire Y is made of different material, different metal, different resistivity. It has same resistance as X but has twice length of X. Which row gives possible values for resistivity and the cross-section area of Y. So as we have Rx equal to Ry, we have rho x Lx, which is L, over Ax, which is A, equal to rho y Ly over Ay. Ly is twice the length of x, so we can write this as 2L, eliminate L with L, and we have rho y over Ay. This ratio should equal rho x is rho, should equal rho over A divided by 2 or multiplied by half. For the choices given, if we divided rho y, resistivity of base y, over Ay, and choice A, this will give rho over A, which is not equal to the ratio we found. Here it will be rho over 2A, this is equal to our ratio. Cell of electromotive force E, MF E delivers a charge Q to an external circuit, which is correct. Energy dissipated in external circuit is E times Q. We have E equals work over Q throughout the whole circuit. So energy dissipated in the external circuit is not correct. It is the internal and external and the internal circuit. I think this is the right answer. The diagram shows a circuit with a battery 60 volt and negligible internal resistance, 20 kilo ohm resistor, thermistor, voltmeter, and resistance of thermistor is 20 kilo ohm. Temperature of thermistor decreases and this causes the resistance to change by 50%. After this change, what is the reading of voltmeter? So firstly, we should get the current before the change in temperature to find uh, how the current after change in temperature to find how much voltage is given in the fixed resistor, and as they are connected in series, the fixed resistor and thermistor, they share the potential of the battery or the EMF. So we can after that calculate the we can, by calculating the current after change in temperature, calculating the potential. Okay, so we have R total in circuit is equal to resistance of fixed resistor, which is 20 kilo ohm, plus that of the thermistor, it was 20 kilo ohm, but it is changed by 50% as temperature decreases, resistance of thermistor increases, so it is 30 kilo ohm. So the total resistance is 50 kilo ohm, and current equal 60 volt over 50 kilo ohm. This gives us the current to be 1.2 milliampere. We can simply find the potential across the fixed resistor by multiplying the current by its resistance. Okay. So the answer will be 24. A potentiometer circuit is used to determine EMF EX of a cell. The circuit includes a second cell of known EMF E known and a negligible internal resistance and a uniform resistance wire BQ of known length. EX is less than E naught. Movable connection G can be positioned anywhere along the length of resistance wire. Which circuit is suitable for determining EX? So if we look to circuit A, we will move the G across until the voltmeter reads 0. But the problem is we have the two batteries in same direction. I mean, the current flows from the positive terminal here, okay? And when it reaches this point, it will divide, and this battery pushes the current in the same direction of the incoming current, so this cannot be accepted. With respect to B, although the two batteries are opposite to each other, but we have E node to be on the connected to the movable connection, and E node is greater than EX. Okay, so we cannot reach E0 here on the multimeter. In C, we have the voltmeter connected away from EX, so cannot be accepted, so the only correct answer is D. Principles of conservation of which two quantities are associated to Kirchhoff first and second, certainly charge and energy. An up quark in hadron changes to a down quark, elementary charge is E. What is magnitude of a change in the charge of the hadron? So, as up quark has a positive 2 over 3 E, and it changes to negative 1 over 3 because it changes from up to down quark. The total change is E. Okay, when you subtract minus 1 over 3 minus 2 over 3, it will give you minus 1, which is changed by E. Nucleus of magnesium 23 decays to sodium 23, emitting beta and X. X is electron neutrino. The neutrino is positron, and electron antineutrino is electron. Nucleus of uranium 238 decays in stages by emitting alphas and betas. Betas negative, eventually forming lead 206. How many alphas and betas are emitted? So we know that for beta there is no change in mass number. So if we look to the change in mass number, it will be all attributed to alphas, and this is equal to 32. Alpha has a 4 mass number and 2 atomic, so 32 divided by 4 is 8, so we have 8 alphas, and we should, for the atomic number, moves from 92 to 8 times 2, which is 16, so 92 minus 16, we should move to 76, but we have here 82, which means an increase from the 76 by 6. These 6 are the beta negative. Okay, because as we know, beta negative is resulted from a neutron transfer to proton, so the mass number in the nucleus doesn't change, and the change keeps 32 plus the beta negative and the electron anti-neutrino. So the increase in atomic number from 76 to 82 is due to the number of beta. Thank you for watching and keep following us.